Hello everybody, thank you for being here. My name is Makwana. I am a student researcher at Central College, a student of electromechanical robotics engineering, as well as I am a part of Connectors. So, we all like to eat mushrooms, right? Mushrooms are grown in a dark fields where the humidity and lights are controlled. So, in the places where there is a very dark light, we get the best mushrooms, the best white colored mushrooms. Hence, my project is an autonomous mushroom harvesting device. So our mission is to use a robotic arm, a vision system, and collaborate that for a robot harvesting of a mushroom. My main aim were described by the people who gave me this project. They required few of the things. The required for me is to have the mushroom picked. Mushroom should not be scratched. The mushroom should be always going to the bin after harvesting it, and they require approximately 15 to 20 kilos of the mushroom every hour being harvested as a prototype. It will have a positive outcome for the community as well. So what we are seeing it as people who work at the greenhouses are always exposed to harsh environments. It can always use in like a replacement of people and work in the harsh conditions. Produce that would be harvested by the project would be always of a good quality, as it will be going through my vision sensors checklist, and it will be a consistent output as it is an autonomous guided output which will be getting for the investment. The design and build. I have used an overall TM5000 series robot, which is a collaborative robot, and it won't require any kind of barricades for the people to operate. The robot setup is also incorporated with the 3D vision. This one here is the 3D vision camera, which is an overall camera which I have integrated with the robotic. These two are the photos. One on the left is the tray in which I have 3D printed the mushrooms and used them as a prototype. On the right, we see is the output of the 3D vision, in which I have created 3 segments. One is for small mushrooms, one is for medium mushrooms, one is for large mushrooms. The vision system knows which one are the medium and large mushrooms, and it also has a color coding, hence it will only pick the mushrooms which are of the proper checklist. The weight of the mushrooms which are small are approximately 10 grams, the medium are 18 grams, the large are 23 grams, and there are some mutations in the mushrooms. So my robot is trained in a way, if there is a mutation in the mushroom, it won't click it. This one is a robot gripper setup that I have right now for my gripper. Right now I am also working in collaboration with University of Windsor for a gripper output. So the University of Windsor is also going to give their input for the robotic car. This is my gripper input. This one is a demo image for the robot. So I have programmed it in such a way, with just one play button, the robot will go to the home position, and then the 3D vision system will have a photo capture. The photo will be displayed on the right hand side, and the robot will automatically go to the plum mushroom and pick it up. There will be a slight rotation which will make sure the robot has the mushroom picked up from the roots. And then it will go to the collection bin. I have used a cardboard box as the collection bin for now. Then it returns to the home position and also repeats the cycle. This is a small set of mushrooms that I have placed randomly on the sheet. So as you can see, at first the robot will set the part, then it will orient the setup, then it will calibrate according to the depth of the field. Other than that, it will check 2 variables, that is width of the mushroom and the color of the mushroom. This is a testing unit. After setting the parameters, I tested the mushroom and I make sure the outrun is polished. I have on myself incorporated the safety vision for it. The safety is set for arms as people won't be near the mushrooms, but if by any chance the robot arms collides with like a stationary object or a human, it will get the outputs to the robot and the propulsions will stop at that time. These are the 4 safety segments that I have said. The first one is the robotic arm treatment. Other than that, I have a safe area design. Other than that, I have a work area design. The safe area design is the place in which the robot will work. In the working area, as we have a narrow spaces in the mushroom farms, the robot should be able to go to only in the narrow places. Hence, the working area is used. Other than that, it has a collision function. If it collides, the sensor will know it is a better collision. I was able to successfully receive a grant of 25,000 by a private person who is funding this project, and I was also able to take it to the first step. The next step that I am going to do is have a rail mount at their facility, and everything will be sponsored by them. My name is Makwana, and thank you for your time.
Thank you. So my question is, your demo shows the robot arm picking up the mushrooms, and the mushrooms are sitting in a certain orientation, but they don't grow like that. So how does your application still detect the right size, shape, color when the mushrooms are going in their natural way?
I was hoping for this question. When I met the people, they were precisely considering about the conditions in which they grow. So what I did was I calibrated the axis of the vision system according to the arm of my robot. Hence, it can like easily detect the depth from the robot to the mushroom. Hence, the robot would not require any kind of other inputs, but it being in a place will know the distance between the mushroom and the ball. And by 3D step criteria, so will let the robot know if the mushroom is ready to pick or not. And it can a set of tray can grow approximately 200 to 300 mushrooms on an average. That is the data they give us. So my robot can easily distinguish between every mushroom in that time.
I believe mushrooms grow in a dark environment typically. So I was just curious, in your testing, did you test in a lighted environment or in dark conditions to simulate the growing process?
This is a good question. What I did was, I had specifically called for a vision system which has incorporated lighting. So I would like to show you here. Once the vision system goes to the mushroom, you will see a flash. The flash will make sure that in the dark area, the tray is illuminated by the light and the mushroom will get a feedback.
Another question. So you talked about the benefits from a safety standpoint, but from an output standpoint, what is the rate at which the robot could pick mushrooms compared to a manual operation?
For now, the only thing that is limiting my robot is the ability to process the vision system. It can be easily overcome by a small module which is also available in the market, and the ability of the product to run faster. I am only running it at 5% of its stated speed as it was in a testing environment. I can take it out of the testing environment and I can run it at I guess so much faster speed, more than 5%. I have tested it for 90% and it works fine.
So one more question for you. So I can see on the presentation there's a calibration target. So I assume this is a 2D vision system instead of 3D?
No, it's the camera is a 3D camera incorporated with 3D vision. And what I did was, I did 3 markers, and the robot, it is a collaborative robot, hence it had the orientation inbuilt. So after the markers are set, it can know the difference between the ground to the TCP. And what I did was, I had the coordinate system on the tool. So the tool is the robotic arm, and So the coordinates of the tool will always match the coordinates of my camera. Hence, it will always get an accurate image.
So the calibration is used to calibrate the vision system to the robot?
Yes, it is.
One more question related to how do you target the mushrooms? You know, how do you know which mushrooms to pick? Typically, the mushroom farm will have hundreds and hundreds of mushrooms.
What I did was, I went in the vision system, I take a block tool, I also matched it with a pattern tool. So when the pattern of robot like mushroom is matched, oval pattern, with my block, I set the block to accuracy of pixels, and after testing approximately 100 mushrooms, what I did was have the base pixel density and then match it with the pattern, and that will give me very accurate.